In additive manufacturing with powder bed fusion technology, it is possible to manufacture complex parts which are difficult to manufacture with conventional manufacturing processes. In powder bed fusion technology, an energy beam melts metal powders and builds parts in a layer by layer fashion. But before these technologies can be used to replace conventionally manufactured parts, the processes must be investigated thoroughly. My research, among other things, is to investigate and understand the fatigue behavior of alloy 718 manufactured by powder bed fusion processes and related to its microstructure. The questions that I try to answer include: how good is this fatigue performance? Can it match the cost or rot alloy 718, or can it be better than that? For my work, I perform a lot of fatigue testing in which the loads are varied dynamically. For example, to mimic the conditions in an aircraft engine component, for example, when it's taking off in high altitude cruising or when it's landing. After a number of such tests are performed, it is possible to evaluate how this material is performing. If it turns out that the additively manufactured material is at least as good as, or even if it performs better than the cost or rot counterparts, then there are huge benefits in terms of flexible design, lightweighted structures, and reduced costs for the industry. That is my work.